Today we are going to discuss about a user defined data type allowed in C, which allows a programmer to group together a number of data objects of different data types. And what we are going to see today is about structure in C. So what is structure in the C programming language? It enables a programmer to group a finite number of data items called fields or members of different data types into a single data objects. Examples will make it clear. You consider an example here. You can have a structure in C to define a compound data object with the following composition. So within the compound data structure, you can have a field username, which is a character array, and within the same data object you can have another component, account number, which is a long integer, and the third field or member is account type, which is a character, maybe SB account or current account, just a character used to indicate which kind of account it is. And the last is account balance. There is a typo, and it could be a double precision real number. So we need structure in a C program which enables creation of heterogeneous data objects. Heterogeneous means this kind of a data object which is a single data entity which is composed of fields or members having different data types. Here 4 members are there. One is a character array, another one is integer, then a character and a real number. And if you recall, an array is a homogeneous data object. Even though array allows a programmer to group together a finite number of elements under a single name, the array name, all the elements must be of the same data type. For example, you cannot have an array of size 4 to represent a bank account or the details of an account holder, if these are the details. And we will discuss about more concrete examples. This is just an abstract introduction of what are structures or why we need structures. We can now look at more concrete examples to realize why we need structure. As the first example, you consider a point in two-dimensional space. You have a point P. How will you represent the point P in a C program? Whatever we have discussed in this C programming course, how will you represent the point P? One possibility is you know that you need to represent the x coordinate and y coordinate values to represent a point in two-dimensional space. So you can declare two variables, namely x and y, of type float to represent a point in the two-dimensional space. This is one possibility, but this is not a good option because a single data object, which is a point, is here represented with two different variables which are not grouped into a single entity. They are two different variables. In that respect, it's not so advisable. As another example, you look at a circle in two-dimensional space. If you ask the same question, how will you represent it? We need to know which are the factors which uniquely identify a circle. You have to have a center point P, center of the circle, characterized by its x and y coordinates, and in addition to that you need the radius of the circle also. So the center point and radius can uniquely identify a circle. Now according to what we have, you can have three variables x, y, these coordinates, and r, radius, all of floating point type. This is one possibility, but here again it's not a good option because a single data object, which is a circle, is getting represented by three different variables. They are not related in memory. Before we formally introduce this structure, let us look at one more example. Suppose in a program you want to maintain these details about the students in a class. So you need to, for each student, you need to remember her or his roll number, name, and date of birth. Suppose this is what you need. So a student is a single data entity, then how will you represent? Maybe you can declare a decimal variable for roll number and two character arrays for name and date of birth. The character array can hold the name, another character array can hold the date of birth as a string. But here again it's not a good option because same reason, single data object is represented using different variables or arrays. Also here, if you represent the date of birth as a string in an array, then if you want to access the month or date or year, then it is difficult. You have to extract in the, that from the array. So you need to have a programming logic to do that. So now we have seen some real life requirements for you as a C programmer to group together different data items of different data types, but you need to treat it as a single data object in your program, and that is possible by using a compound data type which you can create in your C program, which is what is called a structure. So now we can look at a very concrete example for structure and see how we can represent all these example data objects using structure permitted in the C language. So we can have a very concrete example. Here there is a function foo, and if you look at a structure is declared, please don't worry about the syntax, that we will see later very formally. Here P is a variable of compound data type, namely structure in C, which is a composition of two variables x and y. In this particular case both are having float as the value. Maybe here you can use an array. The first cell can contain the x coordinate and second cell can contain the y coordinate, but in general you may need two different data types. Okay, so you are now declaring a single data object P which is having two elements in it, x and y. X and y are called the members or fields of the data structure variable P. P is called variable of this structure. Now if you look at the execution of this function, during the execution of a program, suppose this function is invoked or called for execution, then from the previous lectures it's very clear that at the time of calling the function instance of that function will be created in the memory, which includes memory allocation for its variables. If you look at foo, only one variable is there, which is p. P is getting memory allocated. You can see that 4 bytes are allocated for the first component, which is x, and 4 bytes are allocated for the second component, which is y. The assumption is that a floating point value needs 4 bytes in memory. And if you look at this data structure carefully, p is the variable for the whole data structure or data object, and which is composed of 2 elements, x and y. Okay, this is how you can represent it. Now, if you look at the execution inside this function, this is a declaration. So, it comes to the first executable statement. What is it? A member x of a structure variable p can be accessed by the syntax p dot x. So, the field x of p is represented by p dot x. So, it says you assign 2.5 to the component x of p. So, if you execute, what will happen? X will get 2.5. So, that is what is happening. And the next statement is p dot y is equal to 2.1. You know what is going to happen. If you execute this, you will get 2.1 assigned here. Okay, and thus it finishes. And for simplicity, we shall depict this memory allocation as follows. So, p having 2 components, x and y. And not that x is actually allocated in memory, depending on the data type, it needs that many bytes. And now we can look at certain aspects of this particular data structure. You can see that the address of the whole data object p is 501. That is the starting address of that object. And it is also true that the address of x is again 501. Okay. Assuming that this compiler is not using any header information about the data structure. Okay. Now, you can try it in your lab and see what is the address of the whole variable p and also the address of the first variable, and see what you are getting. You can try to print ampersand p dot x using %u. Now, what is the address of p dot y? It is 505. And if you look at p dot x, what is it? It is the value of the variable x in p is referred to as p dot x, and the address of p dot x is like this. And similarly, p dot y is the value of the y field of p. So, this is what a formally structure looks like in C. So, with this very simple example, I think now you are a little confident to define a structure, but it remains us to discuss what is the syntax of defining a structure variable, which is what we are going to do now. Definition and declaration of a structure in C. We can try to understand with this card, and here if you look at, this is the keyword used to create or define a structure. What is the keyword? Struct is the keyword, followed by a compound statement within which all the members are declared, and this is the structure variable. In the previous case, we had a p as a point, and here another name strvar. In general, you can give any identifier as the variable name, just like any other variable name. And these are the members. Finite number of members could be there, and what a member can be, it can be a variable of any data type like x or float, or it could be an array of any data type. So, as a member of the structure, you can have an array, one dimensional array or two dimensional array or three dimensional, whatever you need you can. Or you can even have another structure variable defined inside. Okay, don't worry about it, we will see an example today. And in the next class we will see another compound data structure which is union. And if you have such a data type defined, you can have a member of it. You can also have a pointer variable that we will discuss later. And this is what I already introduced here. You can have a variable of another structure or union. You don't have to worry about these two cases that we will discuss later. Now, equivalent to this, you can write this. So, what is the difference? If you look at, you can see that the struct and curly brace is actually in between. You are giving a tag name. And what is the tag name? Tag is required to specify the composition of the required structure in the variable declaration. If you look at here, directly the variable is declared as a part of the structure definition just after the curly braces. Here we are declaring the structure variable. Okay, and if you want to declare a number of structure variables, you can separate by comma just like any variable declaration. But here we are separating it. We have to declare it later after the structure definition. Then here to indicate which is that structure for which I am going to declare a variable, every structure must be given a tag. Suppose you have two structure variables, structures defined. Then how will you say that, okay, I need a variable of the first structure? You use a tag in the first structure and you specify it here. I hope you are getting me. Otherwise, please don't get worried. Later examples will make it very clear. So here what we did is, in the right side, definition and declaration of the structure are separated. Here is the definition and here is the declaration of variable. And that you can do in any place after the definition of the structure. So this is how you formally define and declare a structure. Two equivalent forms are there. We can look at a concrete example. So if you look at here, what I did is I declared a structure with two fields x and y. Actually here is the structure for a point in two-dimensional space, and the point variable is directly declared here. Equivalently, we can do this. Don't declare here, but use a tag name. A meaningful tag name here is point. Then you can say that P is a structure. What is that structure? This is the structure, because this is the tag used. And not that if you do this, later you cannot declare any variable of this kind. Okay, but if you do this, you can have these kind of statements anywhere in your program. And that is the use of tag name. Now we are going to see what are user defined data types in C. So why we need user defined data type is, we are going to have new data types like point or circle or rectangle or a student or an account. So it will be helpful or more readable the program is if you can define your own data types. And now we are going to see how is it permitted in the C programming language. User defined data types. So I am trying to explain this using an example. You can see that here typedef is a keyword. Then I am saying just like int height. So this is actually a redefinition of the keyword int. This meaning is that, okay, now after this statement, int and height are having the same purpose. Okay, this is actually giving one more name for the data type int. Typedef int height means now height can be used instead of int. That is what I did here. Okay, so this is an existing data type and this is the new name that I am going to give to this existing data type. And why I need? Maybe I need to declare variables to represent heights, then it is more meaningful to have height as the data type. If you want so, you can do it, otherwise you can directly use int. Okay, that's it. Can be used to give a new name to an existing data type, and more interestingly, it can also be used to give a new name to a compound data type which is being defined like a struct. If you look at here, see, I am not using a tag name here, but if I prefix type def in the structure definition, then whatever I am giving here as identifier is not a variable, that is actually the name of the new data type. So when I use type def here, tag name is not required, then whatever I do here is actually the name of the newly defined data type, and that is why after this I can declare a variable of this structure as point p. So here again, this is the keyword type def, then the newly defined data type in the blue color, followed by the name given to that data type. If you look at here, it's again the same, keyword type def followed by an existing data type followed by the new name. The only difference here is that it is not an existing data type, but it is the data type being defined. Okay, this is how a programmer can define his own data types. So the syntax is this: the type def keyword followed by all the data type name followed by the new name, or it could be a newly defined data structure. And now the syntax for declaration is use this data type and then just declare the variable. Now using that, we can have a concrete example, which is the structured data type for a circle. Here is it. Look at this particular function foo, within which I am declaring or defining a new data type, point, using type def. Point is a data type, is a compound data object with two fields x and y. Okay, and then I am defining another compound data type called circle. What is it? Using type def, I am defining a new data type circle, within which I have two members or fields. First one is sender, which is a variable of type point. So sender is having both x coordinate and y coordinate. Another one is the radius. Okay, now using the new data type circle, I am declaring a variable c. Maybe we can see how we can access the members or fields of the variable c. The center, which is actually a point in two-dimensional space, can be accessed as c dot center, and we know that center itself is a structure. So if you want to access the x and y coordinates, this is how you do. C is a structure, dot center is this field, which is a variable of another structure which is having two fields x and y, and radius can be accessed like this. And I think now it makes sense why we need user defined data types. Now let us proceed. Okay, if you recall the examples, we saw how a point can be now declared using this newly defined data type. Now a circle which makes use of a point. And the third example that we discussed was student, and if you want, you can have a program or a function for declaring a student data type. For that, I am defining a new compound data type called date, which is having three fields: day, month and year. Each one is unsigned. Now using that data type, I am defining another compound data type, namely student, which is having three fields: the roll number, which is an unsigned integer, name, which is a character array of length 50, and the third one is date of birth, which is a variable of this structure. Okay. Now suppose I want to maintain the details about all the students in a class of 67 students. I can declare an array of this structure. Okay, student is the new data type. I am declaring an array of students. That is, name of the array is students. Each one is an element of this structure. Okay. Then how will you access? The fields of the I plus 1 the student can be accessed as. Why I say I plus 1 is because you know that in C programs the array index starts at 0. So the first student is represented by the 0th index, second by the first index, and that is why the I plus 1 the student by the index I. So how will you access? Students at I is the fields of that particular student. Roll number is the first field, name is another field, and if you want to access each character in the name, how will you access? So this is the name field and jth character of that name. So it's just an extension of how you do it. And date of birth, if you say DOB is just the date of birth, it is having three other components. Dot day is the day field of the date of birth, dot month is the month field, and dot year is the year field. And if you want to access the date of birth as a single object, it's just DOB, and but that is a structure variable. And with this we are finishing this lecture, and today we have seen how structure can be used to define a new data type for you, and which is a compound data type which enables you to group together a finite number of elements of different data types. Each element can be a variable of any type including structure, or it could be an array, or it can be even a pointer that we will discuss later when we learn about pointers in C. Thank you.